Hey YouTube, today I wanted to talk about router on a stick. So in the previous videos we did some basic switch configurations, we got some VLANs created, we created a trunk between switches, we set up spanning tree protocols so no loops would form in our network. But what if we want some of the traffic that is on, say, VLAN 10 to talk to traffic that's on VLAN 20? In this example, VLAN 20 was our server network, so obviously end users are surely going to want to talk to, you know, servers. So how do we go about doing this? One such method is doing what's called creating a router on a stick, which is placing a router in the switch environment and connecting a link from the switch to the router. Now this link needs to be a trunk so we can pass all the VLANs across it. Otherwise, one could connect a link for every VLAN, but again, that doesn't scale, just like if you tried to pass multiple VLANs from one switch to another switch. So in this environment here, the router was connected to the switch on port Ethernet 3.3. So this port has to be configured. So let's go to our switch. We'll go into global config mode, interface 3.3. We'll give it a description, call it router trunk port. We'll set up our encapsulation. Helpful if we remember the trunk. And then we will tell it which VLANs we want allowed on it. And then we will set it to mode trunk. Okay, so since this is a switch connecting to a router, the switch must go through, the spanning tree states of disabled and forwarding, or listening and learning, depending what version of spanning tree we're running. But before it can start passing the traffic. But the question is, does it need to? A router will not participate in spanning tree as it is a router and it doesn't create BPDUs. So what can we do to speed up this convergence? We can use port fast, but this is a trunk, so we have to add a keyword to the end of that command, which is trunk. So let's set that up. Spanning tree, port fast, trunk. Okay, the configuration is now complete on the switch. The trunk is created, and the port is even going to instantly begin passing traffic since we set it as a port fast trunk. Now we need to turn our attention to configuring our router. So on the router, all of the configurations that will be needed will be done on the interface. So on the router I'm going to be using, I need to first no-shut the interface. So let's go into global configuration mode, Ethernet 00, and no shut. And now with a router, it's a little different than a switch where you just make it into a trunk. We can't do that on a router. So to fix that, what we will do is we'll create sub-interfaces on the router. And to create a sub-interface on the router, we need to type, interface et00, and the new command is dot and then some number. Now generally what one does is they set that number to be the same as the VLAN number corresponding on a switch. So again, I'll do 10. So now we are in sub-interface command config mode, and in here we want to tell it to understand what encapsulation the .1q tag is. So we do encapsulation .1q and then the VLAN number, and this is VLAN 10. And then the final step is to give this an IP address. So we will give it .1, and it's a /24. So now we can verify this. We can hop on our computer and try pinging the gateway. See? Now you'll notice the first ping failed. This is common because usually a device has to ARP, get the MAC address for the IP, so there's just some time before that happens. But after that, you can see our pings succeed. So now we need to do this for our VLAN 20. So we'll create that subinterface .20 encapsulation .1q 20 IP address 10.10.20.1 255.255.255.0, And there we go. The configuration is complete. Now for the interface. Now a couple commands that are helpful to verify IPs on a router. Let's get out of this. We can use the show IP interface brief. I like to use the pipe exclude unassigned. And then we see just the interfaces that are up. If we didn't use that, we'd get everything, that pipe. So I do like to use that to speed up some of our searches. So now we should be able to ping between the VLANs. So I have the two computers. There's the IP on the one, the IP on the other one. So let's see if I can ping that. And I can ping it. We'll just verify if we can ping one way, we should be able to ping the other. And there it is. Now, as we can see here, the device can now ping between the VLANs. You can see there is some latency here. It's not bad. 2 milliseconds. What is it over here? Yeah, 3 to 2 milliseconds. Going from one VLAN to another. It can be a little bit slower because we have to send it up the trunk to the router and then back down. So in the next video, what we'll do is we'll see if we can improve that performance by configuring these gateways to be on the switches themselves. So thanks for sticking around, and I hope you learned something.